So last time we finished by asking, what happens if we have two black holes perfectly lined up to create something that's officially known as an Einstein-Rosen-Podolsky bridge, named after the three scientists who worked together to develop the theory, but is colloquially known as a wormhole. The original concept was that it might be a way to circumvent that light speed limit. If going around through the whole course of the universe took, say, 500 light years, but the distance through the wormhole and out the other side was a distance of only, say, 50 light years, well, then you could appear to travel faster than light. You'd still be traveling slower than light in local space, but faster than light relative to other objects at light speed. You'd get there before light would. Well, then that would seem to provide a way to break that speed limit and to transport through the universe. So this was a very exciting concept, and science fiction writers are still digging into it today. For a good example of that, I recommend Stargate, first the movie, and then the SG-1 was the first of several TV series that spun out from it. Good stuff. There's actually an episode of Stargate in the first season that has a more accurate depiction of black holes than I've seen anywhere else in fiction, including Disney's movie The Black Hole, which gets a shockingly large amount of it wrong. But anyway, the question is it possible? If black holes are supposed to trap you, could you actually come out the other side of a wormhole? Well, at first, the math seemed to say that yes, you would. You could accelerate enough on one side that you could come out the other. And because of the way that radial dimension and the time dimension trade places, you could actually come out faster than the speed of light when you hit the other event horizon and come out. So it appeared that they had a way to do it. That fell apart when Kip Thorne, notably, and others studied what happens to the structure of the wormhole when something goes in. As it turns out, wormholes are unstable. If something falls in one end, that has a ripple effect. And this bridge, made by two black holes that are perfectly lined up, would suddenly warp and distort. And then these two perfectly aligned ends wouldn't be perfectly aligned anymore. You wouldn't have a wormhole, you'd have two completely different black holes, and you'd have already fallen into one of them. Not a pleasant end. Now, Kip Thorne did come up with something called, well, it's one of a class of things called exotic matter. He did figure out that if you have a piece of matter with very specific properties and you put it right in the opening of that wormhole, then it would act like a wedge or a doorstop and keep that wormhole open while you could go through and come out the other side. So how exotic is this exotic matter? Well, exotic enough that it has properties we have never seen, and exotic enough that we have no idea how to make it. It was basically wishful thinking, pie in the sky. What would it take? There's no guarantee that it would ever actually exist. Now, Kip Thorne also wrote a book called Black Holes and Baby Universes. I cannot recommend it enough. It is a very clear, non-mathematical way to explain black holes and general relativity in much more detail. I can heartily support the purchase of this book if you are at all interested. I can also support it just to support Kip Thorne. Thorne just turned 80, on June 1st, 2020 here. Now, a lot of these guys are not pleasant people. I'm not going to repeat the story in a video for our high school, but if you look into why they say black holes have no hair and find out the etymology of that phrase, you'll see what I mean. But Kip Thorne actually won the Nobel Prize in 2017 for his work in general relativity, specifically with the LIGO detector, which detected gravitational waves for the first time. So they detected the remnants and the echoes in the universe, the ripples in space-time that were caused by two incredibly massive black holes colliding and forming a single black hole. So that was a monumental achievement. And it was a long time coming. It took about 20 years. In fact, it was actually November of 1996 that things were just getting started when Kip Thorne came in as a speaker at the Canadian Undergraduate Physics Conference, or CUPC, in Guelph, Ontario. This was my second year as a physics undergrad, and I was one of the delegates that went. Now, there was a day where he was the keynote speaker in the morning. And then we get to the afternoon. Before we get to the afternoon speaker, there was a lunch with Kip Thorne. Now, during that lunch hour, we actually had a chance to sit down and talk to him about the project. I was one of the delegates there, asked him a couple of questions. Nothing really special, is mostly just to talk to him as he was talking about the LIGO project that would develop and detect gravitational waves. And there was a man with a camera who kept coming up to Kip Thorne and speaking with him. Now, this lunch was scheduled from 12 to 1. The afternoon speaker started at 1:30 and ran until 3:30. This was the closest thing I've ever come to skipping class. Because at 3 p.m., Kip Thorne was still talking to the students who chose to hang out at lunch. And I was one of them. There were a lot of them. The guy with the camera kept coming up and whispering in his ear, and Mr. Thorne would whisper back, and that happened over and over the course of these few hours. Until finally, Kip Thorne just lost it. He stopped whispering and said, "Look, I am here for the students. You either take my picture when they're here, or you wait." At which point the photographer stood aside for a couple more minutes, then took a bunch of pictures with students around, and stormed off. Meanwhile, Kip Thorne was still there talking, answering questions. The lunch that had been served to him around noon, 3 hours prior, was barely touched. And he was still talking and answering the questions, no complaints, not a worry. I found out from one of the conference organizers 2 days later that they never would have dreamed of suggesting this lunch. They wouldn't have imposed on him because he is something of a legend in the physics community. They were amazed they even got him for this Canadian conference. And when he came in and asked if he could do it, this was one of his conditions. Not just, come in, take a gratuity check, which is officially optional, but very common. To do that, he wasn't worried about the gratuity, as long as they covered the expenses to get him there and back. He really wanted to interact with the next generation of students, see where their interests were, and communicate directly with them. So I was incredibly impressed with the man and the way he conducted himself. Anyway, so that is it about Kip Thorne and about wormholes, which also wraps up our 5-day introduction to relativity.